So to start with the wrist braces, just as I had shown before, we're going to begin by building that computational model within the NTOP platform. So in this case, we'll import scan of someone's hand, and we can convert that to that implicit modeling geometry within NTOP. Then you can generate that design space, offsetting that initial model, having a bounds of where you want that kind of a wrist brace to be, and then apply the desired latticing, texturing, other additional features that you might want. And so that we can put this back onto the patient, you can split that model, apply any additional connectors as well to that part. And so this would be kind of that first step. We create our workbook, our notebook, our NTOP file. And then what I did is I also have all the key inputs that I might want to address and change into the top of my notebook, and I can adjust and fine tune in real time to see what makes the most sense. So we can adjust those bounds that this video shows, as well as changing the thickness of the lattice structure, changing the arm brace, and outputting that final design. So you can kind of play around and have all those abilities to change those without having to kind of go back into your notebook and adjusting those. And on top of that, you can also swap in and out different lattice structures. So on the right, I have some other patterns that we could apply for this wrist brace. We have some field-driven design in the purple, where we have a smaller pore size of that lattice structure on the ends. And so you can really adjust and fine tune those. And once we have this model as well, we can place in a different hand, a different patient's data, and it will all quickly generate for that use case. So the final process with that would then be integrating that or exporting it for printing, for instance.